The Ocean Universe Theory, Part 4. In this part of the Ocean Universe presentation, we move from the microscale to the ultimate macroscale, the cosmos itself. We will explore the formation and destruction of two of the most amazing phenomena to ever be found in the heavens, black holes and quasars. We will also learn more about the formation and the dynamics of plasma streams in space, and how plasma could form significant enough streamers to affect planets. We will briefly discuss some of the other implications to physics of this fascinating new theory, including trivalent number theory, time and time travel, and even propulsion theory. Finally, we will explore a proposed experiment to verify the precepts of the ocean universe theory. Imagine if all the matter in your body was reduced down to a size that would be smaller than the tiniest grain of the finest powder that you can see with the naked eye. If you can do this, then imagine the Earth reduced to a size smaller than the head of a pin. This is what a black hole is. Or is it? By its name alone, common sense says that a black hole should be empty. Yet physicists would have you believe that it is more dense than can accurately be imagined. If something is so solid, so dense, as the imagined black hole of quantum physics, can it really absorb more matter? Is there a limit to the amount of matter that will fit into an infinitely small imagined space? Perhaps there is a stranger, more exciting, and yet more obvious possibility. One based on something so simplistic that it was simply overlooked by the great mathematical minds absorbed in their complex mathematical quest. What if a black hole is just that? Nothing at all. What if it is just a hole or a void in the ether, the fabric of space itself? The ocean universe theory explores the mechanics of how massive nothing can be. To understand how nothing can be so massive, we need to restate our definitions of what nothing is. In the ocean universe theory, we recognize the existence of energy as either solid matter or fluid ether, much like the relationship between ice and water. In the sense of the traditional vacuum, we define this emptiness as being the absence of all matter. A perfect vacuum, in theory, would not have a single atomic particle in it, but the density of ether or fluid energy would be maximized because there is no matter present to be displacing it. But what if there were possible a volume of space that was empty of both matter and ether, both the solid and fluid states of energy? This would be a void, an area empty of both matter and energy, like a bubble or hole in the fabric of space. The concepts of voids in the fabric of space is conceptually similar to that described by R. Stephen Barry's paper on the void theory of nucleation in liquids. We can think of these voids as bubbles in space. The bubbles form out of the ether, the fluid state of energy, and once formed, they are held open by the internal surface tension of the ether or energy membrane. The internal part of the bubble is a complete void, with absolutely no matter or energy of any significance within it. Without any energy particles in the interior, it is not possible for light waves to transition the interior. Thus, these bubbles would appear as black holes in space. But why would a black hole, a volume of nothingness, appear so massive? Because, as we recall from our earlier discussions, mass is the measure of the displacement of energy. A black hole or bubble in the fabric of space would have virtually a total displacement of energy from within its inscribed sphere. It would appear to be millions of times more massive than the displacement from a comparable sized body of matter would normally account for. But how would a bubble in ether or the fabric of space form to begin with? To help understand how bubbles would form, we can look to the science of fluid dynamics, and more specifically to the study of cavitation bubbles. Many space physicists speak of the electricity of space, whether it is plasma streams, Birkeland currents, electric and magnetic fields, and many other electrically related phenomena. Yet they are unable to explain them at the mechanical level, other than to say they are electrical. But how could someone be assigned the task of actually assembling some of these with this level of information? It is like taking several train cars full of electrical and mechanical parts, dumping them on the floor with a picture of the space shuttle, and saying, "Build it to really fly." We have the information, the mechanical steps, if you will, on exactly how black holes or bubbles in the fabric of space can form, and what happens when they collapse. All of this in the study of cavitation bubbles. Cavitation bubbles are created as a result of a sudden change in the pressure of a fluid, such as water, which will be demonstrated later in this presentation. The sudden localized decompression causes the water to vaporize, expand out, and create a surface tension maintained membrane along the boundary layer between the liquid water and the vaporized water. Now, vaporization can be thought of as an extreme state or expanded state of fluidization. As the vaporized water settles down in its energy, it adheres to the membrane, and the center of the bubble will have been totally vacated. In fluids such as water, cavitation bubbles generally occur on fast-moving objects like propeller blades. But cavitation also occurs when water flows very fast past a fixed object, like a rock or a piling on a pier. Shock, such as produced by sound waves, explosions, or rapid compression, can also cause cavitation bubbles to appear. As cavitation is a characteristic of fluids, and we have seen ether display fluid qualities, cavitation bubbles could occur in the vacuum of space where ether is prominent. By studying the similarities between observable space phenomena, hydrostatics, and fluid dynamic phenomena, such as cavitation bubbles, we can gain a clearer understanding of how electrical currents in space react with gases, comets, planets, and with each other to produce the space environment as we know it. Crucial to developing this understanding is learning about how the fabric of space responds to different stimuli. Cavitation bubbles are known to form and collapse under various defined conditions with well-defined characteristics. Because these characteristics occur when various conditions exist in the fluids the bubbles are created in, we can use the bubbles to tell us a lot about that fluid. We have discussed already that, like their earthly counterpart, cosmic scale cavitation bubbles are giant voids with nothing inside. But cavitation bubbles offer us so much more insight into cosmic scale events. Cavitation bubbles are not only created, but like most bubbles, they burst, and when they do so, they can have catastrophic effects. The stream of bubbles can literally carve through the hardest and toughest materials at breathtaking speeds, from cutting metal parts in a factory to creating vast canyons and landscapes when they accompany flood conditions. The terminology we use in describing electricity was not chosen by accident. Rather, it was purposely decided to use terms associated with fluids, such as current and flow, because electricity resembles the similar conditions found in fluids of solid matter. Thus we speak of current in wires as being like volume in water pipes, and voltage like pressure in water pipes. With this in mind, let's see how the power of cavitation may be shown itself to us every morning. As we have said, cavitation bubbles, like all bubbles, eventually collapse or implode. And when they do, they release vast amounts of energy and force. While it is imploding, the fluid around it rushes in, and then rebounds back outward with great force. And while minute bubbles collapse in fractions of seconds, bubbles in space trillions of times larger could take millions or billions of years to cycle through the whole collapse and rebound sequence. But let's look at a real cavitation bubble being studied at the University of California, Los Angeles, in the following video clip.
The star in a jar, a tiny spot of bright light contained in a flask of liquid. This star in a jar is made when a sound wave is passed through a small bubble inside a flask of liquid. And this sound wave makes the bubble do something remarkable. First it expands, then it collapses. And this collapse happens so violently that vapor molecules trapped inside the bubble slam together and heat up so much that the bubble gives off an incredible burst of heat and light, several thousand times a second, giving the appearance of a star. What made the phenomenon so exciting was the temperature of this star in a jar. On its surface alone, the light burns at tens of thousands of degrees.
Cavitation bubbles are only now beginning to be understood and explored more thoroughly. The research is leading physicists down many unexpected paths, with some researchers recording temperatures in excess of 1 million degrees inside imploding cavitation bubbles. These oddities of fluid mechanics may hold the answers to why the Sun and other stars continue to give off vast amounts of radiation over extremely long periods, while other objects, like the quasars, release even vaster amounts of force in extremely short periods. Let's look at how the power of these bubbles can be extrapolated up to the dimensions of heavenly bodies with an eerie sense of accuracy. For thousands of years, humanity has looked to the sun in wonder of the immense heat and light that continues to be emitted millennia after millennia without relenting any noticeable amount. Yet today, with all our science and technology, we still have yet to explain at the mechanical level how the sun can continue to exist. While in the far distances of our universe are other bodies known as quasars, millions if not billions of times more intense and powerful than our sun. While on the one extreme, the most popular theory, still unsubstantiated, is that the sun is a vast nuclear reactor fusing hydrogen into helium. On the other extreme, quasars are said to be caused by the massive gravitational collapse of a black hole. Today, an exciting new theory is gaining momentum, which is attempting to explain the sun as a massive electrical discharge between oppositely charged regions of space. And while this theory is not widely accepted yet, the evidence is building against the fusion model, at least as we understand it today. But what if there was another model that was able to tie all these loose ends together? One that was consistent both at the stellar and quasar dimensions. The ocean universe theory clearly explains in mechanical detail how both the sun and quasars are just various scalar occurrences of the same phenomena, while providing a detailed explanation for the electrical interactions that create the plasmatic body we call the sun, which is able to collapse the weakest of atoms into its next biggest brother. All of this is demonstrable by the fluid dynamic phenomena we call cavitation bubbles. If we scale up the time it takes for a cavitation bubble to collapse to the size of a quasar, we find that the first collapse of a cosmic bubble would take almost 2 million years, with the energy of release scalable relative to the size difference of some 10e to the 30th joules. Today, scientists around the world are exploring the powerful and stimulating phenomena of plasma in its various forms. Correlations between the effects of plasma events in high-voltage laboratories and plasma cutters used in industrial settings are being found in pictures of Mars and other planets. The evidence is building to a point that a new theory on planetary scarring by plasma etching suggests these events occurred over and over again in our solar system. Even on Earth, there exist geological formations that cannot be adequately explained by erosional and geotectonic forces alone. In this section, we will see how electrical plasma is the distance covered of hydrostatic cavitation fluids. The correlations are more than uncanny. They can be mathematically modeled and physically demonstrated. We have to ask, is it possible that the great outbursts from giant objects in the heavens can be a form of cavitation on a cosmic scale? We will explore all these similarities to show that cavitation actions in the universal ether are the cause of plasmas in space. Previously, we have seen how cavitation bubbles and fluids here on Earth can be used to model both black holes and quasars in the distant reaches of our universe. We have seen how a cavitation bubble can shine like our Sun, with temperatures matching those we see on its surface and in its corona. Now let us look how cavitation in fluids here on Earth demonstrate all the visible phenomena seen in space-based plasma streams, such as deep space ribbon plasmas and Birkeland currents. In the video on the left, you will see cavitation bubble streams flowing from an ultrasonic horn, while on the right, still shots of space-based plasma events will be displayed for comparison. Let's watch the video. We will watch this video one more time before we move on, and notice this time how the stream of cavitation bubbles flow directly down away from the ultrasonic horn. As they move away from the horn's surface, the streams begin to wrap around each other, just as we see in Birkeland currents. As we will see shortly, cavitation streams like this have the power to cut through rock and the hardest metals with ease and accuracy. plasma and fluid cavitation models mimic each other too closely to be merely coincidental and unrelated to each other. The electrical phenomena now being recorded in deep space, around and in the Sun, and in the vicinity of and on the surface of our neighboring planets, suggest that what we thought of as empty space is in fact filled with an ether or medium that behaves with fluid-like qualities. Electrical currents and other electrical phenomena seen in the heavens behave just as their cousin phenomena seem to behave in fluids here on Earth. In the pictures on the right is a picture of a cavitation bubble exploding in zero gravity, and a picture of a distant quasar-like object in space. Notice the similarities. Now let's look at a short video from the European Space Agency about cavitation in zero gravity. In zero gravity, a cavitation bubble collapses in a manner that is consistent with what we see in deep space objects, and perhaps more importantly, on our own Sun. Ejections from a cavitation bubble collapse clearly mimic solar coronal mass ejections, as seen here in a picture from the Solar and Heliospheric Observatory. When a cavitation bubble collapses, it goes through a series of rebounds before finally collapsing completely. While a bubble of just a millimeter will go through this whole process in less than a second, a cosmic scale bubble might take thousands or millions of years to complete a whole cycle, with thousands of years of stability between phases. One question that this raises is, if our Sun were to mimic the life cycle of a cavitation bubble, then where would it be in the collapse and rebound cycle? While many astronomers and space physicists have surmised, for the lack of a better theory, that craters, deep and wide crevices, and mountain ranges on planets and moons in the solar system are the results of ancient volcanic and meteorite activities, as well as that comets are nothing more than snowballs of dirty ice, some scientists around the world, working with the Thunderbolts Project and other groups, using some of the latest data from satellites and space-based telescopes, have uncovered credible evidence that many formations we thought of as geophysical or impact-related in origin may have been formed by electrical actions such as plasma streams. These plasmas, as demonstrated in laboratory experiments, are believed to be capable of causing the large valleys in many of the craters and mountains. One objection to this theory involves how the plasmas arc across the vacuum of space. The terms electrical and magic are similar in one significant way. They both describe the outward appearance of an activity without giving any details as to how the activity is actually accomplished. So in essence, saying the current flowed through the wires and saying the rabbit was pulled out of the hat relies on the same information of these two events, virtually nothing. The ocean universe theory provides the mechanisms for these plasma streams to exist, and to move across what appears to be empty space. It also provides for a physical model in which to demonstrate here on Earth that these theorized plasma streams could produce the planetary scarring found on Mars and other planets. Let's look at some examples of comparisons between Martian terrain and cavitation etching in the following video. Waves, currents, flows, and pressure gradients or fields do not occur in nothingness. They require a medium in which to exist. One of the most compelling examples of a medium-based phenomena is that of plasma streams. While their existence and effects are known fairly well, the mechanics of how they form, besides being induced by high voltage, has yet to be described. In the ocean-universe theory, plasma streams are described by applying the physics of cavitation bubble formation and collapse in fluids of matter to the fluid energy or ether which fills the vast expanses of space. All of the effects of space-based plasma streams and plasma etching can be modeled in a physical laboratory configuration of cavitation bubble generation in fluids, right here on Earth. While understanding that space is not filled with physical matter, such as water, or gas like hydrogen, or solid particles like iron, we have now new or re-evaluated evidence to suggest that what has been generally described as energy for the last 100 years and ether are one and the same thing. Ether is not a form of matter. It is that matter is a crystallized or solid form of ether. It is because of this fluid-like state of ether compared to its crystallized state as solid matter that we can explain phenomena such as plasma, light waves, and gravity in a simplified and unified theory. The ocean-universe theory provides us with an exciting reassessment of how the universe around us operates. We have seen some of the more prominent areas of this theory within this presentation, but there is so many other areas of technology and science that this theory touches, which can help improve the understanding of science and the quality of life for humanity. For instance, if we think of our current maturity of space travel as being analogous to a caveman riding a log in a stream, then the ocean-universe theory provides us with the fundamental knowledge to give that caveman a powerful new jet airliner. As advanced as technology may seem, it has reached the upper limits of the science that supports it. Systems that we see in our science fiction movies are not developable because they are fantasized based on science principles that cannot support their existence. While the concept of instantaneous is widely debated, a practical and verifiable proof of its existence is found in the phenomena of displacement. Displacement, as discussed in the ocean-universe theory, is a causal effect phenomena that is reflected in gravity, which is instantaneous in its action. Another important construct of the ocean-universe theory is that of the digital nature of time. When modern theories of time were being established in the early 20th century, the world was analog. Analog movie film, which became the metaphor for time, established a forward and backward theory of time. Today, in our digital world, we seldom think of analog imagery anymore, as we deal in SD microcards and internet cloud accounts for storing our digital photographs. Many young people don't even know what film is. So why is it when we speak of time, we always do so in analog rather than digital terms? The ocean-universe theory brings time into the digital age. From propulsion theory to subatomic theory to the meanings of time and gravity, the ocean-universe theory unifies energy, force, and matter with a single demonstrable causal effect model that explains the phenomena we see from the subatomic to the cosmic. No theory can stand without experimental verification, and the ocean-universe theory is no different. We propose an experiment to measure the speed of light striking a moving object. Unlike prior experiments, this one will measure the speed at which the light beam can transfer a digital message to a moving target, while this part of the light beam carries the same message to a stationary target. The difference between the receipt of the same message at the two targets will verify that the moving target was actually moving faster than the speed of light relative to the light beam.